I would make a short overview about the highlights since our last workshop a year ago. Surprise, surprise, a year ago. So there have been a couple of changes during this year, and we have changed the project and the team. So the GÉANT 4.3 project ended last year, and the GÉANT 5.1 project started in January this year. And the infrastructure cloud frameworks with commercial suppliers are still in operation for the 2016 and 2020 frameworks. The services delivery chain continues to suppliers, NRNs, and institutions. The difference is that earlier the support for service adoption was also required. Now the users have matured. In addition to the currently available frameworks, we are preparing for their continuation, the new 2024 OCRA framework, as we call it. From this year, a procurement team is working on it. They were formally operated in the OCRA project. And right now, the prior information notice is out for the suppliers to provide feedback until 9th of October. So it has been published in Tenders Electronic Daily. If you're interested in learning more, please look it up. Also, as infrastructure cloud has shown the highest value in the community so far, both building and buying, a strategy team has been added this year to gain a clear picture of the new roadmap and strategy for the next few years, outlining what can be jointly done for the research and education institutions in this area. Development continues, but with a slight difference. Instead of developing what we can, we are first waiting for the strategy results regarding the community's demand and NRN's capabilities in this field. The GÉANT 5.1 project is currently preparing the next iterations of the project. Right now, we have started testing the incubator concept for smaller developments, and are also piloting the idea of how to spin out a service offering from the project funding to ensure the self-sustainability of developments. We continue to collaborate extensively with other projects, organizations like EUNIS, infrastructures, and special interest groups. Let me change the slide. As part of long-term planning and monitoring of GÉANT Cloud consumption, we conducted the GÉANT Cloud survey for NRNs and institutions this spring. The survey was also circulated in the EUNIS Cloud group, so we'd like to express our gratitude to all those who send us this information. This survey takes place every 2 and 3 years. This year, responses were submitted from 23 countries, as shown on the map. A total of 140 institutions participated, with most organizations located in Northern and Western Europe this year, in contrast to the last survey in 2021, which had mostly received responses from the Southern and Eastern Europe. Here are some results that might interest you as well. We examined the current use of clouds in general, satisfaction with the current frameworks, future plans and support requirements. An overall picture indicates fewer organizations that exclusively buy or build among universities, so hybrid cloud usage appears to be the trend. Satisfaction with suppliers and services was slightly lower than with the 2016 framework, but it's worth noting that 2020 OCRA framework was much more complex than this 2016 piloting one. This time, we have learned how to better prepare for the 2024. And satisfaction with NRN support and their services has remained consistently high in both surveys, which is reassuring. And an increase in infrastructure cloud services consumption is expected also in the future. So far, our joint efforts appear to be reasonable, let's say. It also appears that the community has matured as the demand for training had decreased compared to earlier years, although it is still considered the most helpful means to increase services usage. And the most interesting topics for universities were security and cost control. And accordingly, we have focused our joint workshop topics in this direction. So also today we have cost optimization and billing distributions. The same priorities were among the top 3 for NRNs, security as the most important, but followed also by cost control and legal aspects, which received the highest ratings in the 2021 survey. Now let's take a moment to update also about the EIAS framework consumption. Here is a map showing 27 countries consuming services from the current 2 frameworks. We aim to expand to more countries that were previously unable to join 2020 OCRA framework due to some legal issues as non-EU countries. This graph illustrates the increase in institutions using the services from 2017 to the present year. By the end of June 2023, this year, a total of 900 institutions had used the services, but keep in mind that this figure for 2023 covers only half a year. But as you can see, the increase is cumulative and extends already the figure about last year. And lastly, this graph displays the cumulative consumption of the 2016 and 2020 OCRA frameworks amounting to 205 million euros. Perhaps another time we can delve into the interesting aspects of how these frameworks have saved effort, money, stress of people. But all in all, that concludes what I intended to share with you today. And thank you for listening.
So yes.
Okay, then I will just continue. Hi, everyone. I'm Denise, and I'm the lead of the Cloud Special Interest Group at EUNIS. And because there were so many new participants or so many registrations, I just thought, because there's not many new news since last year, I thought I'd just give you a wrap up about the Special Interest Group in EUNIS in total. And if you do not know, EUNIS stands for European University Information Systems, and we have members from higher education or research institutions, for example, like NRENs, educational organizations, and we organize regular events, for example, this webinar today, or we also have our annual Congress, which is in Athens next year, so you can also, everybody save the date for this event already. It's always at the beginning of June. And in EUNIS, we have special interest groups, for example, the special interest group on cloud management, but we also have other special interest groups, just like GÉANT on information security and all those topics. And this special interest group here, cloud management, is just a platform to exchange the knowledge we have, discuss current topics. That's why we always ask what is driving you the most today or in the next month. Because we want to help and exchange the knowledge so that everybody gets benefits from it. We have a lot of online joint workshops with GÉANT, but also some workshops alone. We have a mailing list for discussion. If you want to join the mailing list, just send me an email. I'll write the contact here and we will provide the slides later. So you can just contact me if you have any questions to that.
Good morning, everybody, and thank you for the opportunity to talk about trusted research environments this morning. So my name is James Grant. As Denise has just said, I sit in the UK Education Solutions Architect team at Amazon Web Services, and I have a research focus. So I work with higher education organisations, primarily within the UK, on research topics. Before joining AWS, I did a couple of postdocs and then was a central research software engineer at the University of Bath. So I've got a bit of history of working with researchers, research compute IT systems, and also then engaging with the wider community. I joined Amazon about 2.5 years ago, and for the last year or so, I've been working closely with our education trusted research environments in the UK. I think Peter is talking after me, and he's going to talk about do a bit of a deeper dive into a solution we have, trusted research environments on AWS. So I'm going to give a bit of a background perspective on trusted research environments. So hopefully what you'll get from my talk is a little bit of an overview of trusted research in the UK, and in particular, what are TREs? And I'll try to use the acronym from now on, otherwise we'll get a bit bored of hearing those same words over and over. Also, why should you consider a TRE, and what are the benefits? Whenever you're having conversations about TREs, it's really important to make sure that everybody's understanding the same thing. So I'll talk about some of the different ways in which people can think about TREs as well. One thing to say is that I've been working closely with this community for the last year, but in some senses I'm a bit of an imposter. TREs have a history going back well over 10 years. The first one that I'll talk about here, Sale Data Bank, started really around about 2006 with the initial pilot in 2007. So Sale Data Bank is operated by Swansea University. And it hosts health and administrative data to allow population level research across the whole of Wales. So they're ISO 27001 compliant. They are accredited under the Digital Economies Act, which governs data use and particularly use of public data in the UK. And they also have statistical disclosure controls in place to make sure that data that's outputted from their environments, it doesn't contain any sensitive information. Another national level project in the UK is Research Data Scotland. That includes a network of TREs at the national and regional level. And again, the idea here is that it will help accelerate researcher accessing and being able to perform research on those publicly held data sets. Across the rest of the UK, there are plenty of other universities that operate TREs on premises to store sensitive data, host data that they receive from health trusts perhaps, or to enable researchers to work with data in secure environments. And the important thing really is to be able to implement security and data movement controls. Couldn't get through the talk without doing a little bit of AWS customers that are using running TREs. So a couple of examples here of significant national projects are Genomics England. They work with a partner, LifeBit. Initially, they hosted 100,000 whole genomes from NHS patients with rare diseases, their families, and also cancer patients. But that's ramped up to 5 million genomes, and they want to make that data available to researchers and partners so that research can consume the data and deliver value and public good. The second example here is UK Biobank. Again, they worked with a partner, this time DNA Nexus, and they're looking at providing genomics researchers access to the data that's held by the UK Biobank project. Again, the volume, the sensitive nature of that data presents challenges in broad open access. As well as being able to provide secure access to the data, they want to be able to provide the scalability so that they can respond to researcher needs as and when their projects come in. Another project that we've done, and this is what Peter's going to be talking about in a bit more technical depth after me, is the trusted research environment on AWS solution. So in conversations with particularly education customers, they were wanting particularly an open source solution, or a solution based on open source solutions that were already in the public domain. And they wanted to provide a self-service solution to secure and analyze sensitive data. So the point here is that researchers can consume AWS services without having to have technical detail of how to manage those directly. So effectively, one of the core components is a web application that manages that infrastructure for you, and enables researchers just to focus on their time to science. This can be delivered by our professional services or partners, and these are just some of the examples of how you could build a TRE on AWS, and we're very open to have conversations and help you to make the best decisions for your particular use cases and requirements. So I've talked a lot about TREs, but why would you want them and what do they really do? So do you have researchers conducting health research, hosting sensitive personal health data that they've provided from data controllers, or potentially commercially sensitive data? Your researchers are going to have research data management plans, most likely. They'll have done ethical reviews to govern the way in which they should be working. But what compliance requirements do they have? Do they know? Do you know? And what measures are in place to enforce those? Personal information is often collected via surveys as part of research. So personal identifiable information rather than necessarily health information. How are researchers currently storing that potentially disclosive data? What controls are in place to provide secure access to explore that data, but also to restrict data movement? And then more generally, in terms of how cloud can help deliver value for TREs, if you have existing provision, are researchers limited in the resources that they can access? Would they benefit from being able to use different hardware, to have access to different databases perhaps, or native services that can help them move up the stack, directly consume machine learning services for image recognition or analyzing medical records? In terms of terminology, there are a lot of different names in the space. I've used TREs, the session is around TREs, but there are a lot of other terms around, and some of the examples are here. Data safe haven, well, safe haven is actually what the Scottish network is called, not TRE. Other things here, secure, isolated virtual research environments. A key one that's growing in visibility certainly are secure data environments. So there's a significant piece of work underway in the NHS in England to create both a national and then regional SDEs. The focus, the objectives and the outcomes that these are seeking to deliver is slightly different, in my view, from TREs in the education research space, where what purpose is quite different, but the functional requirements, being able to surface data, enable users to consume that data in a secure way, is a similar set of requirements. So we're also working in that space, both with customers and partners. Okay, then just going to go a little bit of a deeper dive into what a TRE really is, though. There's three key references here: the Office for National Statistics and their 5 Safes framework, which I'll go into a bit more detail on. But there's also a couple of links on the slides here. Those understand will be shared with you afterwards. One of the sources is the UK Health Data Research Alliance. They wrote a green paper on TREs and then a follow-up paper exploring how to go about building TREs in the cloud or generally. Another of the papers, and this was one that came up repeatedly when we were having conversations with customers in the education space, was a paper from the Alan Turing Institute in the UK looking at data safe havens in the cloud. That's a really good reference. It covers several different areas, both around classification and how to think about the requirements for a TRE as a whole on an operational side, but also in the context of individual projects, the data and the way it's being consumed. Going back to the 5 safes, these are quite clear and the definitions are given here. So safe people. Organisations running TREs need to make sure that any users that are working within a TRE are trained and accredited, and there should also be an audit trail for them. So the definitions here aren't exclusive. In terms of safe projects, it's really important in terms of justifying why the data can be used in the first place, that any projects are identified for the value that they're going to deliver, that it's ethical research, and that it's going to be delivering for that public good. It's an absolute key component in terms of enabling access to unconsented data in many cases. In terms of safe data, what's key here is that the researchers only have access to the data.
Okay, thanks, Eva.
Okay, so safe settings. We need to provide a controlled technical environment where researchers can access their data securely, where they're accessing through, for instance, a secure desktop, which can limit egress of data from the solution. Then we come on to 5 safe outputs. It's all very well preventing the release of data, but at some point we want the research to get out. And in order to do that, you need to have a process, information governance people involved, people who are familiar with the data, who can review outputs to ensure that the data doesn't contain anything identifiable or at an individual level.
Excuse me, James, you have 2 minutes left.
Thank you. So I'll hurry along. One of the things I really wanted to highlight was what people are thinking about when they say TREs. So in one context, they're thinking about the technical solution that provides the safe setting. But I think whilst it's important to do that, that's what TRE on AWS provides. That doesn't, just because you can deploy that doesn't mean you're running a TRE. In order to do that, you need technical solutions or appropriate technology being used at each stage. So it's all very well having trained and accredited users, but you also want to make sure that you're using an identity provider, that you have appropriate multi-factor authentication in place. You want to make sure that you're auditing those projects. You also need the whole information governance alignment with the whole flow of data and projects through the system, and you also want the appropriate technology in place all the way through. Just sort of coming up to the last couple of pieces then, so we've got a minute or so left. There have been a number of recent government reviews and NHS reviews in the UK around trusted research right now, but also requirements for the future. Ben Goldacre led a review titled Data Saves Lives, setting out how the UK can use the extensive and diverse NHS data to save lives and improve health outcomes globally. Part of the response to that has been the creation of DARE UK, which is the Data Analytic Research Environments organisation. And they've released they've done a number of things, a landscape review, they've funded a couple of sets of projects looking at public involvement and community groups. They've also proposed a federated architecture blueprint for how in the future TREs might be able to access data in a federated way across different data controllers and a wider ecosystem. That's in a way similar to the European Health Data Space Initiative. And a couple of projects that I really want to pick up on because I've worked quite closely with them. If you're interested in building a TRE, how can you evaluate what you're already doing and what can you evaluate potential solutions? So the University of Dundee have been leading one of the DARE UK projects, SATRA, the standardized architectures for TREs. And this has been really looking to how you translate ISO 27001, Digital Economy Act, Statistical Disclosure Control. How do you translate that into practice? What are operators doing at the moment? What does the community at large expect from TREs? And they've released an open source, well, there's a GitHub repository and then an open source specification describing what the community has contributed in terms of understanding TREs. So I'm over time, I'll stop there.
Thank you.
Yeah, so can you see my screen share? Okay, perfect. So basically, I want to talk a little bit about TRE at GWDG. So maybe first a short introduction of GWDG. It's a rather complicated name to pronounce in English. So we are a research-focused IT service provider for the Max Planck Society, which is the third largest research institution globally with 86 institutes, and also the University of Göttingen, and of course also other academic institutions and R&D communities. We are also ISO 27001 certified, so security is very important for us. So we carry out also our own research in applied computer science and HPC. We are one of the 8 national centers for high performance computing. We are also one of the 2 HPC sites of the German Aerospace Center, DLR. And we are also one of the core players in the German Research Data Initiative. And recently we have also become one of the 4 national AI service centers targeting AI applications, especially in the fields of medicine and energy. So there you can already see that, we have a quite high focus on the secure processing of data. And that's also why TRE was very interesting and important to us. So first let me also mention that the TRE work at GWDG was enabled by the EOSC future tender regarding the distribution of commercial cloud services, which was also supported by GÉANT. And the tender was about the distribution of commercial cloud services in the different R&D communities in Europe, and it addressed the OCRA partners and also European research aggregators. And we as GWDG, we teamed up with Rackspace as an OCRA partner and also AWS to develop and provide a trusted research environment in our infrastructure for the different research communities that we serve and focus on. Yeah, motivation for TRE. Some of the things James already mentioned. So basically, from our perspective, researchers do not really want to deal with servers or any kind of technical IT infrastructures. They have the need to use IT services or specific IT services to solve the specific scientific problems to advance their research. They need to collaborate and with other researchers that are also often located in other research institutions. So there is the need to centralize data, provide centralized infrastructure, and share this data with collaborators. And they also want to use common services. So basically, they do not want for each of their research projects to start from scratch and learn new ways to deal with new services. They basically want to have a common platform for their workflows and basically reuse what everybody else is already using and what they have used in the past. And the research, of course, also needs to be reproducible. So for one, this is important to validate the research results. And on the other hand, of course, it's also very important to broaden the impact of the researchers' work. And of course, especially with the advent of AI and deep learning, they want to be able to access state-of-the-art analytics and want to run the latest infrastructures that supports these analytical services, and also with a scale that is possible in the cloud. And they also want to use it at any time and scale it depending on the demands. So yeah, and of course, one major issue is that researchers are no cloud or security experts. Yeah, so they don't know about virtualized networks, different types of storage, all the different IT services that are needed in the infrastructure to provide the services they want to use. So in the end, they need some kind of well-structured, pre-configured environments that simplify the consumption of cloud services, that provide catalogs of pre-configured products that they can just consume for the research. And of course, this also allows to implement the best practices regarding the technical aspects of the services and also security. And yeah, from a provider perspective, or from the IT perspective, it's of course also very important to ensure that auditability, security, governance, the tracking of costs, and all of these aspects are also addressed inside such an environment. And of course, it needs also to be easy to add new services. It needs to be sustainable, upgradable, and all of the things that are required for modern IT infrastructures. And yeah, regarding the processing of sensitive data, of course, it's also extremely important to be compliant with the regulations. And for that, like James also mentioned, it's important to support complex workflows in the solution. And yeah, exactly there, the trusted environment on AWS solution comes into play. So like we already heard, it's a self-service solution for processing sensitive data on AWS. It basically consists of aggregation of AWS services, so that for one, allow the secure hosting of data, but also provide the analytical tools to analyze this data. And there is a high focus on security and compliance, and of course, ease of access and use of the provided resources. Yeah, this is a basic architecture of the environment or of the solution that is provided through TRE. So TRE defines different roles for the stakeholder in the projects. And it basically implements or helps to implement complex workflows that control the flow of data through the different components of TRE. So this is especially critical for the ingest of data, but also, of course, for the egress of data. Yeah, here this is shown in a little bit more detail. I don't want to go through all the steps because it would take too much time. I just want to mention that there is a data lake provided with S3 as backend storage, and yeah, a multitude of services that allow to analyze this data. And for example, currently we as GWDG work together with Rackspace and AWS to extend the number of available analytical services to provide also HPC cluster-based services to analyze the data for the researchers. So this is also one rather complex example of how the onboarding workflow in TRE could look like for a research study that is dealing with medical data. Of course, this is an extreme example. It's also possible to tone it down for less demanding use cases. And this is maybe also one aspect that is special for the GWDG deployment of TIE in comparison to other deployments of TIE. So we don't want to just use this infrastructure for processing of very sensitive data like medical data. We also want to use it for more general use cases, because like we have seen, the advantages are also in the ease of use and for researchers, and also in the ability to make the consumption of cloud services more secure and easier to handle. So these are also aspects that go beyond the use of TIE just for medical or very sensitive data. So here I have also a summary of the TIE gains from our perspective. Yeah, like was mentioned multiple times, security and compliance and ease of access are probably the major problems that TIE helps to solve. But one very interesting feature of TIE for collaboration is also that it's possible to onboard AWS accounts from other institutions into the environment. Yeah, so it's also possible to collaborate easily with already existing infrastructures on AWS that are also managed by other institutions. So this is a screenshot of how the TIE currently looks like. So we are still not finished with providing or implementing everything. So it's a little bit of a work in progress. But yeah, most parts are already running, and we are currently onboarding our research use cases into this environment. So yeah, as a conclusion, cloud services are increasingly in demand in the European and German R&D communities. The direct consumption of cloud services by researchers poses certain challenges in different areas, like, for example, security, governance, compliance with regulations, and data safety, that are quite difficult to satisfy without some kind of central infrastructure that is provided for researchers. And a trusted research environment based on the TIE solution from AWS helps to address all of these challenges, and basically allows us to provide this secure, structured, and low threshold processing of data on AWS for our researchers. So thanks. That was it.
And as we just heard, working on making the cloud services accessible and usable for the researchers. It also needs to work on the institutional level, and they need to be able to understand some of the differences that a consumption-based, variable consumption cloud service can bring to the table, but at the same time also use some recording and analytics of the cost structure to achieve some of the savings and the efficiencies that cloud services can bring. So therefore, cost management is a bit of a field for some relearning and some new avenues for optimization and innovation at institutions. And we have two speakers here today who will present their perspective on these. And that is firstly from SURF, the Dutch Research and Education Network, John Segers, to share some of the experiences from there. Thank you very much. John?
Good morning, everyone. Thanks for inviting me into this session. I prepared a little presentation on what we at SURF see how our institutions deal with cloud cost management and accounting and billing. And I was thinking beforehand, what should I present? Because I mainly have the SURF perspective, and we have a fairly particular role in the OCRA framework. We are an underwriter. So we are, between the cloud providers and the institutions as far as billing and invoicing is concerned. For most of the other NRENs, you are referrers, and the invoices flow directly from the OCRA providers to the institutions. So that puts us in a unique position, I think. And well, the downside is that our position is different from the other NRENs. The upside is that we have more visibility into the processes from the cloud providers to the institutions as far as billing and accounting is concerned. I'd like to share a couple of slides. What I wanted to do is talk a little bit about cloud cost management in general, and that's also to do with the process. I've got 2 slides on that, I think. Cloud billing, another 2 slides, and cloud accounting. Too, and if we have time left, I also have an example of things that we often talk to our institutions about, how to purchase cloud, whether it's pay as you go or you make a longer term commitment, like a reservation for Azure virtual machines, for instance, but that's optional. If we look at setting up cloud cost management, I first have a question for you all, that is on slide number 4. If you're trying to keep up the agenda, there's a slide for the agenda. If we share the slides, that's nice to have a look at that. But this is really the first slide, the question for you all. Which role in the organization can deliver the largest savings in cloud spend? Does anybody have any suggestions? No, nobody.
Underwriter.
Yes, somebody.
Yes, I said the role underwriter because they have preferential costs.
Yeah, so we indeed, as the underwriter, you have lots of visibility in consumption. But this is more about, if you know your consumption, who do you need in order to optimize your spend, to reduce the consumption and still achieve the same outcomes? Now, we don't need the answer right now, something to think about during the presentation. Let's go to the next slide, please. So if you look at the large cloud providers, the hyperscalers like AWS, Azure, and Google, and also Oracle and IBM a little bit, they have these well-architected frameworks. And the well-architected frameworks are about helping their customers adopt cloud in a systematic way. And those well-architected frameworks, they're built on a number of pillars. And one of those pillars is cost optimization. They all have that. If you can press space, please. Cost optimization is not the only pillar in those well-architected frameworks. And it's not even the only one that has a relation to optimizing your cost, to cost management in the cloud. Because some of the other pillars, like operational excellence, is also about keeping track of what you're doing and feeding that information into a process of deciding to make changes. And again, as an example, if you see that you use a lot of VMs in the cloud in your institution, you might want to buy reservations, make like a 1 or 3 year commitment, and get a discount. So that operational process should really tie into the cost optimization process. And another one that I think is important, that's also where really we're moving towards the answer to the question I just asked, is performance efficiency. And performance efficiency is about making sure over time that you're using the service that is the most efficient for the task that you're trying to do, for the compute or storage task that you need. So for instance, you have an application that uses virtual machines. Might it be more efficient to use containers? What do you need to do to containerize that application? And would that translate to cost savings? Or if you need to store data with an application, often what people are familiar with before they move to the cloud is they use file shares. But maybe the somewhat reduced functionality of object stores is sufficient for that application and is way cheaper in the cloud. And that's also where the answer to the question comes in. The people who can give you the largest savings when you start migrating applications to the cloud or building applications in the cloud are the system designers. They need to become cost aware. They need to be familiar with the different cost models that the cloud providers have. What data goes in, the number of gigabytes I store, or the number of compute hours or minutes, or whatever the dimensions might be, and then think about what is a cost-effective solution in the cloud. And what we see at SURF among our institutions is that maturity still needs to grow towards taking that into account when you design systems in the cloud. What we see when people talk about managing their cloud cost is, well, related to what we just heard in the previous presentation, making sure that the invoicing and billing is correct, and internal chargeback or getting separate invoices are the concerns from your procurement and financial departments. And the overall communication to optimize across the board between different teams, that's where we see room for improvement. If you can go to the next slide, please. Now, if you get to a stage where you are making decisions on what are the most effective services in the cloud, you still need to, I guess, create a loop where you can improve continuously. And that's where the accounting and billing process comes in, and the communication from what they're actually using into how can we further improve. And when you improve, your usage changes, and then you can look again at the accounting and billing information that you receive to see whether there's more room for improvement. Now, on the next slide, I created a sort of a flow chart. Oh, we are a bit too far, I think. I am looking at slide 7. Yeah, this one. Yeah. Sort of a flow chart of information from the cloud provider on the left towards invoices and usage summaries on the right. On the right-hand side is the institution that gets invoiced and who get usage summaries. And on the far left is the cloud provider, say Microsoft Azure. Now that we see, as an underwriter, we see 3 different models, I would say. I'll start at the bottom. The third one is applicable to Microsoft Azure. So in blue is everything the cloud provider does. In red is what the NREN does, in this case SURF, and in green is what the cloud reseller does. So if we talk about Microsoft Azure in Germany and the Netherlands, that would be Bechlen. So for some cloud providers, there's no reseller involved. They offer their services directly. And in our underwriter role, we get invoiced. We add in a not 100% automated process our NREN charges, our cost recovery charges, and then we invoice the customer. And the usage summary doesn't necessarily go through us. So the cloud provider can send a usage summary to the institution, and they can have a look at that and track, how are we doing in different projects, what are we consuming, or by department or faculty or institute within the large institution. And that's the easiest model. The second model is one that is applicable to Microsoft. They report in their own internal systems the usage, and then they will apply the OCRA discounts to that usage. So what Microsoft does in effect is every month they load a new price book into their system on their end with the discounted rates for all of the SKUs, the Azure SKUs that they have, and that changes month over month because they introduce new SKUs. And then based on that price book, they calculate the actual usage in euros at OCRA discounted rates. There are providers who internally, calculate first in dollars, apply discounts, and then convert to euros. Not exactly sure how Microsoft does that. But the outcome is that, in this case, Bechtle, the reseller for Microsoft Azure, receives an invoice from Microsoft in euros with the OCRA discounts applied. And then they have their processing. They need to do some reconciliation because the data from Microsoft, there's sometimes some issues with that related to how you set up indeed enrollments, tenants, and accounts. Sometimes a manual fix needs to be made. We get invoiced by Bechtle. We do our cost recovery on top of that, and we invoice the customers. And the most complicated one is, well, an example there would be AWS, where we also working with a reseller, Rackspace in our case. And AWS is different from Microsoft in that internally they only do usage and usage reporting at list price and in US dollars. So directly from AWS, you cannot get usage information at OCRA rates. It's only list price and only dollars. So the partner, Rackspace, they do all of that conversion stuff, applying the discounts, converting from US dollars to euros, and then sending invoices. So that's more work for them. And we also run into like different questions from our institutions, and in also looking at the invoices and the usage information. There's some challenges sometimes. With Rackspace in the past, we had quite some challenges in getting the data egress waiver applied. That was apparently very difficult. A lot of line items in the usage information they get from AWS that they would need to apply, the discount to. They get invoiced by AWS, and then AWS retroactively applies the data egress waiver, but they need to make sure that in the usage information they process, the 100% discount is applied to data egress. So a fairly involved process. We had quite some issues with that, but fortunately that got resolved. As an underwriter, our role is different. So we actually get invoiced by the cloud providers or their partners, and we invoice the institutions. So for us, there's also some form of financial risk, right? We have to pay somebody, we have a contractual obligation with them, and then we need to get paid by the institutions. Now, I think that's enough about the billing process. Let's go to the next slide. To discuss what do institutions want. One slide back, please. Number 8. So indeed, in line with what we just heard, split billing is a feature that many institutions want. So they want to receive separate invoices for all of their internal users of cloud, the different faculties. It's hard for them to set up internal chargeback, so they'd rather have different invoices for different projects or research programs or faculties. Every time we ask institutions about this, that's something that's important to them, and it's quite a bit of work. And in Aachen, they did that work themselves. A very nice process there. We are working to do that as well for all of the OCRA providers that are being used, and it requires more work because it's not just Microsoft and the process there that we need to deal with, but also the other cloud providers. We've been working with Bechtle for a number of months to get this set up. And to be able to send separate invoices to the larger institutions who want those split bills. There is technically another way to do that within the institution, but it requires a change of process within the institution. It would make our life easier if that could be done. And we sometimes talk to institutions about that. Today, we are at a joint Microsoft Surf event, and in the afternoon, I'll do a presentation on that as well. But we would like to convince our institutions to actually use cost tagging more in the cloud. And then it becomes easier for them also internally to investigate the usage summaries and to see which costs are borne by which departments or projects. But by and large, if I look at sort of the maturity level of how people deal with the ever-changing cost of cloud because of the pay-as-you-go models. The communication lines between procurement and finance on one hand and IT departments on the other hand should be strengthened a bit. We have an example of one university where there was a strange change in the cloud bill that was observed, where the finance department asked us for help because they saw their bill go from like 5,000 euros to 100,000 euros in a particular month. And that institution in the IT department, they had already built a solution that takes all of the usage data from Azure. They built logic apps and Power BI dashboards to be able to show internally to everybody who uses Azure what is their consumption. And they could also see that difference, but the finance department didn't know that. So they didn't know that internally they could get the answer to the question, why has our bill spiked? So communication is important. And I think that's also a key point if you want to grow your cloud adoption. The more you spend, the more important it becomes to keep that understanding of what are we spending our money on and who is doing it, and is that within the plan? That's the other part you want to check, right? So if we transition to the next subtopic, accounting, the cloud providers, they all have their cloud cost management portals. And this is an example from Azure. It's a dummy figures, actually. It's an example from Microsoft themselves, their infamous Contoso organization. And it's really important if you want to understand in more detail how you're doing, what am I using, or am I using more than I predicted, to be able to track that and to maybe even forecast. It's a good starting point for organizations who want to get in control as their consumption grows. Here, this graph just shows consumption over the period of a month. This is the month of October, so by October 22nd, this is the actual number from the left of there, and then the prediction towards the end of the month. But you can also group cost by service used, or if you indeed tag resources with cost centers, you can group by cost center. And there's also functionality in these portals. Maybe you can see it on the left-hand side in the menu. There's this thing called budgets, where you can set budgets for your cloud consumption. So, and on the budgets, you can set alerts. So if something, if your consumption is higher than you expect, you get an alert. And you can get alerts on actual consumption and also on forecasted consumption. And that's really key. And I must admit that a lot of our institutions don't do that yet. We have well over 100 institutions who use cloud via Serve Cumulus, so under the Okra framework, and only a handful of them actually set up these budget alerts and cost anomaly detection. That is something we're trying to drive up, so that also in case of events that really are bad, maybe an account gets compromised and a hacker starts consuming resources, you want to be aware of that. You see a sudden spike in consumption, you need to act. That's also, I think, an important part to cloud cost management. If you pay by consumption, you need to track your consumption. If we go to the next slide, please. If the cost management portal of the cloud provider doesn't provide you with sufficient detail to track your usage by project, and historically, the cloud cost management portals allow you to group cost, but they don't allow you to basically slice and dice at will along multiple dimensions. What you can do as a user is you can download the detailed usage and charges. Here again is an example from the Azure portal, but that is also the case for the other large cloud providers. If you do that, you can feed that information into the tools that you build yourself or that you buy elsewhere to basically break the usage information down, create graphs, create tables, track changes. You can do a lot of things. We have a sort of particular setup for Microsoft Azure where many institutions are departments in a single enrollment. And that also allows us across all of those institutions to check for sudden strange anomalies. It allows us to do checks against the invoices that we receive from the reseller. And we sometimes find that indeed there are some errors in there. So we do that internally. The Azure Cost Management Portal doesn't provide sufficient detail to do that. So we download the charges, convert them, and created a BI solution to be able to get the information out that we need. Institutions can do that as well. I gave an example of one institution who do that. They get this Azure data in a storage account. They build some logic apps to transform it and load it into a database and use Power BI dashboards to get out the information that they want. I'd like to see more of that happening for the larger institutions. We need a step up in maturity of how they consume cloud and how they deal with it. If we can go to the next slide. This is the last slide, really. Where do we see room for improvement? Well, I showed you that flow chart of the invoicing process, and that process is really there's manual steps in there for the different parties involved. It's error prone. It takes long. So hopefully going forward in the next iteration of the OPRA framework, we can make that go quicker. That's also better for institutions. If you consume in the month of, let's say, June, and you only get invoiced for that in August, that's a complete month gone. It would be nicer if you actually get that invoice in July. Another place where there's room for improvement is that the tools offered by the cloud resellers. So, for instance, Rackspace has their own cost management solution for the AWS consumption. They use Cloud Health, so it's actually a product from VMware. And that uses proprietary data formats and APIs. So if you want to build on top, you are bound to the tool from the reseller. And if in the next iteration of the framework, we don't use Rackspace as a reseller for AWS, but another one, then you need to migrate all of that tooling. So one thing I hope we can make happen is that any reseller will actually reuse the same data format as the original cloud provider behind them. So AWS has a certain data format for their usage files. If the new reseller, whether that's Rackspace or anybody else, can deliver the usage records in that exact same format, but with the discounts applied, that will be very helpful. And then finally, I talked a bit about the process within institutions. Communication lines can be improved, and I think that will benefit everybody within the institution. The users, because they get more insights on what they're doing, the procurement and finance department, because they can get more control, and also to optimize, because some of the optimization options, coming back again to making reservations and long-term commitments, they work better across a larger base. If you have a small department who have, let's say, an Azure subscription, where not much goes into it, it's hard to optimize by making reservations. If you consider all of the subscriptions within a single institution, across that larger base, it's much easier to say, okay, we can commit to a certain usage, get a discount, and then basically statistical multiplexing helps, right? Somebody shuts something down, but somebody else spins it up, and you still get a discount applied. So that's it basically for me. I hope that was interesting for you.
I do not need introduction. That's very nice. Thank you. Okay, let me just, okay. So arrange my screens again. Yes, here I am again. I'm talking about not EUNIS now, but what I do at our university in Aachen. And the topic is accounting and billing in the cloud. And we are doing this on the example of Microsoft Azure. And just a quick introduction to our university. We have around 47,000 students, which was last winter semester. I'm not sure how it is now, but slightly more probably. We have more than 9,000 employees, depends on how you count. I included the third-party funding here, so there's more than 9,000. They are working at 260 institutes divided to 9 faculties. And also we, just like Piotr said at the GWDG, we are also one of the centers for high performance computing at the Aachen University, and we are also part of the National Research Data Infrastructure. I'm working at the IT center of the university, and we provide central services for the university like network, mail, virtual infrastructure, high performance computing, and we of course support processes like student lifecycle management and research data management. And what are we doing at Microsoft Azure? We are running some kind of a test phase since 2020. We started with 5 use cases with just a few institutes. Currently now, 3 years later, we have 22 use cases. They are not many because they are limited and each use case has to be approved. So this is why there are only 22. The contract we are using is, of course, the Okra framework, Okra Cloud framework. Our reseller is Bechtle that we have in between. And our main issue, this is why what I'm talking about now, is we, because we have an enterprise agreement, the contract is an enterprise agreement. In standard, we have only one bill for our whole tenant. So as you can imagine, if we have 260 institutes which all have their different use cases, this is quite a big of a number. And of course, it is possible to do some kind of internal splitting according to tags or research groups, resource groups or subscriptions or whatever. This is of course possible, but the main problem here is that if we do some kind of internal cost allocation, always the first question is who pays the bill first. So if there is a bill coming in from Bechtle for the monthly consumption in Microsoft Azure, who pays the bills and from which budget? Because this is not, there's no central budget, but we have distributed over those institutes and the use cases. So there is no central budget to pay this bill from. And also there are questions like who manages this payment and what if an institute does not pay immediately, who cares for all these processes? There's no, no employees who do this. And furthermore, as I said before, we have a large third-party funding, and some of those processes or some of those fundings parties need a proper bill. So if you have internal cost allocation, this does not count, and you cannot send them the whole Microsoft Azure bill and saying, yeah, part 83 and 57, this is just for this use case. This does not work. Furthermore, concerning cost management, as you all know, Microsoft Azure has a pay-as-you-go model. So the cost you have at the end of the month, this is, sometimes it's a good guess, sometimes it's a less good guess. You have, of course, you have something like the Azure pricing calculator, but sometimes or most of the times the Okra discount we get is not involved in the standard pricing calculator. And also the cost recovery that we pay on top of our consumption is not included in this pricing calculator as well. So yeah, there's even more guessing. Let's put it like that. And always the question is if the costs are only a good guess, what do we do when we reach the budget? So I don't think it's a good solution to just shut down resources because they are services based on those resources, and they are also costs that need deleting. So if we have storage costs, how do you shut down storage? You can only delete the data. That's not a good possibility as well. So what is our structure looking like? This is we have a special tenant just for Microsoft using Microsoft Azure. And this tenant it looks like this. We have, of course, a central Entra ID or Azure AD, as it was called before. And then we have subscriptions. And right now, each institute or each use case has a different subscription. And in this subscription, there are resources or resource groups, for example, Azure Labs, virtual networks, virtual infrastructure, storage, and so on and so on. So this is the structure we are looking at. And so we have all those information. And how do we put it together? So what we did, what our solution was or is, we have one bill for each subscription. That was our goal. The billing is done by not by Microsoft itself, but by our reseller, and the bill is paid directly by the institute. So no one pays it in advance, no internal cost allocation, but directly by the institute. The requirements are that, of course, if we do that, each use case has to be realized in a single subscription. Otherwise, this does not work. And also the responsibility for budget and payment lies within the institute. This is good for us, but has to be stated. And what do we do now? We have, for each new subscription, we generate in SAP, this is our ERP system, we generate a single order number, which is dedicated to this subscription. And then we send the subscription ID, the billing address, and this order number, we send to our reseller. And I see there's some German. Okay, I'll translate that later. And the billing is just produced using this information. So we have a special bill concerning this special information. And our first question was, how could we generate such an order number without placing an order? Because that was not in our processes in the university. There's just an order number if you place an order, but that was for the people who are participating in Microsoft Azure. It was quite a big process. So what we got now is we have a dedicated number range, which is about, I don't know, I think 5,000 or 10,000 numbers within SAP. They are dedicated specially to Microsoft Azure, and they are blocked, so they cannot be used anywhere else. And they are for us, and we can use them as we want, and that's what we do now. So we have a web application where somebody who is authorized to order a new subscription can order this, set the owner, set the budget, describe the use case, and this information is then sent automatically to Microsoft Azure, and there a new subscription is registered. In the background, we also set the owner there and set the budget, so you can just go on and work from there. But when the subscription is created in Microsoft Azure, the subscription ID is sent back to our web application. And then the web application sends the connection between the SAP order and the subscription ID and the institute that orders this subscription back to SAP. So we have in SAP the connection, we have in Microsoft Azure the subscription, and we have all those information together in the web application. We can also add the billing address there, and this is that's just it. That's the single information the reseller needed to print our bill. And this is how it looks like. It's of course in German because we get German billings. And this is the SAP order number. This does not change. And this is printed just within the bill. And because it's an automatic workflow, the bills are just sent via email, and SAP automatically detects this billing order, this order number, and then sends it to the right institution. You also have the institute's invoice address here and the university's invoice address there. They both do not change, so this is all it needs. So this part really works well. We have the ordering and the billing, which is executed within our normal university processes. We can use the invoices for the third-party funding. That's what we wanted. And all the responsibility lies within the institute and not within a central institution. We have no internal cost allocation that's necessary. And everything goes just with standard processes. And our conclusion here was that this process, this workflow really works well for all the costs that can be allocated to a subscription. But the downside is there are different kinds of costs in Microsoft Azure. So there are also costs that are not assigned to a subscription, but for example, to the whole tenant. We have something that's called monetary commitment. I don't know if that's a German thing, but I see some people nodding. That's something like a fixed prepaid credit, and those credits are assigned to the tenant and not to a subscription. So we have this credit, and I cannot tell you how it is used, because it's some kind of miracle for me. At least I don't. It's not comprehensible how this prepaid credit is distributed over the bills for this month. But it's there and it's done. So that's a problem that we have to still solve. And there are also services like, for example, Power Virtual Agents that have some kind of contingents, and they are placed on the tenant as well. So you have assigned contingents to the tenant, not to the subscription. And if you have more than one subscription who wants to use Power Virtual Agents, you have a problem here as well. And of course, there's something like user-based licenses, something like Power BI, and so on. And of course, there the costs are assigned to a user and therefore to the tenant, and not to a subscription. So what's up next for us? We have to find a solution for that as well. So we solved one case, and 2 other cases are still open. And of course, there's the question, Maria just told you that there's a new procurement, and I have to admit that our solution works very well, but it works very well just with the reseller we have. So I'm very curious what 2024 OCRO framework brings to us, and if we have to change something here. And what we also want to do, that's also in our plan, that we want to apply this workflow to other infrastructure suppliers, not only to Microsoft Azure, but we are talking with Google or Open Telecom Cloud. And yes, and furthermore, we also have some multiple projects with ChatGPT, OpenAI, and our usage is very much going up. So we are happy we have the solution already running. Okay, that's it. Thank you very much.